Hello and welcome back to my YouTube channel. Today, we're diving into a story that is, and I'm not exaggerating, completely redrawing the global map of technology. This isn't just a story about another country getting into the chip game. No, this is about India making a massive, groundbreaking leap to the absolute cutting edge of semiconductor design. And that signals a huge shift in who is going to be architecting our digital world.
So, here's how we're going to break this down. First up, we'll look at the breakthrough itself, what I'm calling India's nano moment. Then, we're going to dig into the two pillars that made this all possible, the people and the plan. After that, we'll zoom out to see what this means for the rest of the world. And finally, we'll get real about the challenges and the long road that's still ahead.
All right, let's jump right in. Section 1, the revelation. This is where it all kicks off, with an announcement that officially puts India into a very, very exclusive club.
Okay, so here's the bombshell. At Qualcomm's design center right in Bengaluru, Indian engineers are now designing and taping out 2 nanometer chips. Let me just say that again so it sinks in. 2 nanometers. We're talking about the absolute frontier of what is possible in physics right now. This is a massive deal. It's not just about participating anymore, it's about leading the charge in designing the very future of computing.
You know, it's hard to wrap your head around just how complex this is. Union Minister Ashwini Vaishnav put it in a really powerful way. He said it's like trying to write the entire Mahabharata, the Ramayana, and the Puranas on a single tiny chip. Just imagine that for a second. That is the insane level of density and engineering we're talking about here.
So what's the big deal about 2 nanometers anyway? Why does it matter so much? Well, it's a fundamental leap in what technology can do. See, when you shrink these transistors, these tiny little switches, down to this scale, you can pack so many more of them into the same space. And that means everything gets faster, more powerful, and way more energy efficient. We're talking about everything from your phone to massive AI data centers.
And when I say more, that's a bit of an understatement. We're talking about cramming 20 to 30 billion transistors onto one tiny piece of silicon. That density is everything. It means a single chip can now basically be a full-blown AI computer. And not just in the cloud somewhere, but right there on the edge, powering the smarts inside your car, your camera, or a robot on a factory floor.
And this, right here, is the real story. For decades, India's role in this industry was seen as, the back office, doing support work. But this 2 nanometer achievement just completely shatters that whole idea. Indian teams are now running the entire show, from the first customer request all the way to the final finished chip. This is the difference between being a player on the team and owning the team.
So the big question is, how did this happen, and so fast? Well, it really comes down to 2 main things. Let's start with the first one, which is the incredible foundation of talent that India has been building. Okay, so under its first big semiconductor mission, the government set this really ambitious goal. The plan was to train 85,000 semiconductor professionals over 10 years. That was the long-term vision, to build up the human capital needed for this industry.
But here's the incredible part. Get this. In just 4 years, India has already trained 67,000 engineers. They're not just on track to meet their 10-year goal. They're smashing it, years and years ahead of schedule. It's completely rewritten what everyone thought was possible. And we're not just talking about a couple of universities here. This program now spans 315 universities across the country. And this isn't just textbook learning, Students are getting their hands on the same advanced tools that the pros use, designing and taping out their own chips. What that means is, you're creating a workforce that's ready to jump into the most complex jobs from day one.
All right, so that was the people power. Now for the second pillar, holding all this up, a very deliberate, very well-funded national strategy. Let's talk about the India Semiconductor Mission, or ISM.
The ISM has basically been the engine driving all of this forward. It's approved 10 huge projects, pumping in investments of over 1.6 lakh crore rupees to build out the entire ecosystem. And they're not stopping there. They're already rolling out ISM 2.0, which is all about moving up the value chain, focusing on design leadership, making specialized equipment, and developing advanced materials. And as you can see from this timeline, this is not a short-term gamble. This is a long-term strategic marathon. We've hit this incredible 2 nanometer design milestone. So what's next? Well, the focus now shifts to actually making these advanced chips in India. The roadmap is all about methodically bringing manufacturing onshore, starting with more mature chips and then pushing towards that 3 nanometer frontier by the early 2030s.
Okay, so we've seen what's happening inside India, but why should the rest of the world care about this? Let's zoom out and look at the global implications, because they are huge.
Right now, the global tech world has a very big, very risky problem. Just look at this. Over 90% of the world's most advanced chips are made in just one single place, Taiwan. That's an incredible amount of concentration, and it creates a massive risk for everyone. So where does India fit in? It's emerging as a credible, reliable partner to help diversify that supply chain and make it more secure for all of us.
And this is where India's strategy is actually really clever. It's not trying to just become another Taiwan or another US. Instead of just copying their playbook, India is playing to its own strengths. It's carving out its own unique space, aiming to be the world leader in high-end design talent. It's a really smart move, focusing on a critical part of the puzzle where it already has a huge advantage.
And of course, for India itself, this is absolutely massive. It's a huge part of the national vision called Atmanirbhar Bharat, which is all about technological self-reliance. Because let's be real, in today's world, the ability to design your own advanced chips isn't a luxury, it's a strategic necessity. It's absolutely crucial for things like national security, the space program, and defense.
Finally, while all this progress is just incredible, we also have to be realistic. This is a journey that will take decades, and the road to becoming a full-scale, cutting-edge manufacturer is full of some very, very big challenges.
And these are the big ones. First up, you've got the money. We're talking astronomical sums. A single advanced factory can cost more than $20 billion. Second, there's yield. It's one thing to design a chip, but actually making millions of them perfectly is incredibly difficult. Third, these plants are thirsty. They need unbelievable amounts of ultra-pure water and a rock-solid power supply. And finally, you have the whole geopolitical chess game of getting access to the critical machines you need, which are only made by a handful of companies in the world.
So, what's the big takeaway here? The journey from the back office to a potential silicon powerhouse is clearly happening, and it's happening fast. This 2-nanometer milestone isn't the finish line, but it's a powerful signal to the world that India is now a serious contender in this race. So, I'll leave you with this question to think about. Having proven it can sprint with the best in design, does India have the endurance to win the long, grueling semiconductor marathon?